In the last video, we saw that each one of these forms is really important for something. The factored form is good for finding the zeros. The standard form is good for finding the y-intercept. The vertex form is good for finding the highest point or lowest point on a graph, a very important thing. And usually the standard form is best for finding concavity, but very often someone's going to give us one form and we're going to have to convert it into another. I'm sure you already know how to do this, but let's just talk briefly about how to do this. So what I want to do is say, let's just write things down. To go from 1 or 2 or 3 and turn it in to 2, what do I have to do? Just multiply everything out and combine like terms. So multiply out. Combine like terms. I'll put it over here and get mad at myself later. All right, so to go from 1 to 3 to 2, it's not so bad. What if I want to go from 2 to 1? Well, to go from the standard form to the factor form, we factor. Not a big deal. That even makes sense. Yay. Now, if I want to go from 3 to 1, oh boy, I'm leaving a big gap here. If I look at this thing here, the vertex form, and say factor that, I don't want to factor that. Yes, it looks hideous. So this is what we do. If someone gives me the vertex form and I want the factored form in order to find the zeros, I'm just going to multiply everything out, turn it into the standard form first, and then factor that. It makes a lot more sense to do that than anything else. So let's see here. We can turn anything into 1 without killing ourselves. We can turn anything into 2 without killing ourselves. What if we want to turn something into 3? Yes, into 3. So if I want to turn 1 into 3, I'm going to have to complete the square, and that just looks hideous starting at 1, so I'm not going to go straight to 3. What I'm going to do is multiply everything out first, get the standard form, and then complete the square from that. If I want to go from 2 to 3, as we've seen, we just need to complete the square again. And I'm sure you've already seen completing the square, and I'm sure you don't need a little review, but let's just do it together to make sure that we summarize what's going on and show a nice, reasonably efficient way of doing it. So all I'm going to do is start from 2 and go to 3 and see what we can do with that. So here we go. I want to start with 2. I want to go to 3. All right, 2. I'm going to start it with 2x squared plus 4x minus 30. And I want to complete the square. Well, there are 2 important things with completing the square. The first thing is that number next to the x squared has to be 1, or the completing the square won't work. So what we do is we group together everything but the constant and pull out what they have in common. So this is just going to be equal to 2, and I'm going to have x squared plus 4x. And what we're going to do is complete the square inside the parentheses. So I'm going to give myself lots of space. And the minus 30, I'm going to put way over here. It's just much more convenient. Now, how does completing the square work again? Once that coefficient is a 1, and that x squared coefficient has to be a 1, inside the parentheses, I go to the linear coefficient, which is 4. I take half of it, I get 2, I square it. No, I didn't do that right. If I pull out a 2, there we go. I feel better now. Okay, I take the 2, I take half of it, I get 1, I square it, I get 1, I add it. So this is just adjustments inside the parentheses like that. Yay. Now, I just changed my function. I'm allowed to rewrite my function, but I'm not allowed to change it. So what did I just do? Inside the parentheses, I just added 1. on this whole function then, I took that 1 and multiplied by 2. So I had just taken my original function and just added 2, which I'm not allowed to do, right? So if I added 2 to my whole function, I've got to subtract 2 to undo it. Now, the reason we call it completing a square is because when we get it, inside the parentheses should be something quantity squared. And sure enough, that's x plus 1 quantity squared. Yay! Now the 2 is still there, and the minus 32 is way over here. And you can see that the vertex form that I was supposed to get, we got just by completing the square, making sure that leading coefficient was 1 first, and then making sure that we're balancing this. Whenever we added something to one part, we have to subtract from the other part. I'm sure you've seen that before, but there we go.